Now we're ready for our next lesson, and this one is on graphing our equations again, but this time the equation is going to be in something called standard form. So standard form is similar to what we saw last unit, where it's written in that form that we're used to factoring in. We have an a with the x squared, and then the b with the x, and then c is our last term. So whenever it's in that form, our quadratic equation is in standard form, and we're going to attack it a little bit differently. We need to find the same pieces of information, but it's not going to be quite as easy to find that h and that k to find our vertex. We're going to have to go about it in a little bit different way. So one of the first things we're going to need to do is anytime we want to find the x value, so that's think of kind of like our h value from before. What is my axis of symmetry going to be? Okay. In order to calculate that, since I can't just go find h in my equation anymore, is we're going to take the opposite of b, so b is that coefficient on the x term, over 2 times a, and a being the coefficient on my squared term. We'll get into why this is the case here a little bit later in the unit when we get to the quadratic function, the quadratic equation, but right now we just have to kind of use that to help us find it, and then later on we'll kind of explore how that came about, but we're not quite ready for that part. So that's how we calculate our x value. So our first step is to find that axis of symmetry. Okay, that's what we just talked about up here, how to find our x value, our axis of symmetry. And this is going to take the place of what we normally would have been our h. So this time, instead of just looking at the equation, we got to do a little calculation to find that axis of symmetry, but that's my x value. Then we're going to plug that x value back into our equation. So we're going to plug in for x in our equation, do our math, and see what we get for y. So that's going to give me my y coordinate. So my first little bit up here got me my x coordinate. I plug that into my equation to find my y coordinate. That now gives me my coordinates for my vertex. For our domain in this type of equation, it's still going to be all real numbers. Okay, that's not going to change. Our range, so if our a value is positive, that means it's opening up. Our domain is going to be y such that y is greater than or equal to that k value, that y coordinate of our vertex. If our a value is a negative, meaning it's opening down, my range is going to be y such that y is less than or equal to k, because this kind of has that maximum. But that k value, remember, is our y coordinate of that vertex. So once we find that vertex, we kind of know where that cap is going to be on our graph, either the very bottom of it or the very top of it. All right, so here are our steps, and then we're going to put it to use. We're going to identify our a, our b, and our c. We're going to calculate our axis of symmetry by using this equation to find what x is equal to. We're going to plug that x back into the table, or back into our equation to find the y. Now we know our axis of symmetry. Now we know our vertex point. Then we can make our table of values, choose a couple more points, and then we go ahead and graph it. So a lot of the later part is going to be very similar to what we did the other day. The only thing we have to do is we have to do a little bit more work to find that x and y value for our vertex. So let's put that into use. So first we're going to start with our axis of symmetry. So we need to know what x is going to be equal to. Well, my a is 1, my b is 4, my c is -5. So to calculate x, I want the opposite of b, so -4, over 2 times a, which is 1. -4 over 2 times 1, x is equal to -2. Now I need to find my y value, and this is where I'm going to have to do just a little bit of math. I'm going to take my equation and I'm going to plug in -2 for x. So I'm going to write mine down here just where I have some space. So I'm going to do y is equal to 1 times -2 squared plus 4 times -2 minus 5. Then I do some math. -2 squared is 4. 4 times -2 is -8. And then I've got a -5. add those all together, and I get negative 9 for y. So my y is equal to negative 9, so my vertex is at negative 2, negative 9. Okay. Now, I decide, is it going to have a maximum or a minimum? Well, my a value is a positive number, so it's going to open up, so that means I have a minimum. My y-intercept. So for this one, I can do it two ways. One is I could graph it and see where it crosses. But remember, the y-intercept is where your x is equal to 0. So think about our equation. If I were to put in a 0 for x, that would be 0. 4 times 0 is 0. So I'm just left with negative 5. So my y-intercept would be a 0 for x and a negative 5 for y. Think of it as we put in 0 for x and then solve our equation for y. My domain is always going to be x such that x is all real numbers. My range, since I had a positive y value, or positive a value, so I know it's opening up, it's going to be y is greater than or equal to, remember that k value, which is my y, negative 5. Now I go ahead and plug these into my table of values. So I got negative 2, negative 9. So I'm going to do negative 1, 0, 1, 2 if I can get to it. Plug this into my calculator, and I get a negative 8 for negative 1. I get a negative 5 for 0. I get a 0 for 1, and I get a 7 for 2. So I can fit all of these in here. So I'm going to start at negative 2, negative 9. Then I'm going to go negative 1, negative 8, 0, negative 5, 1 and 0, 2 and 7. And then remember, I can always do my mirror image on the other side. Okay. And then I simply draw my, kind of a sloppy line there. And then I can always want to draw in that axis of symmetry as well. That was my x equals negative 2. Okay. So a lot of the features are going to be the same as vertex form. We just have to do a little bit of work at the beginning to find that axis of symmetry in vertex. All right, so let's do another one together. So again, sometimes it's helpful to label your A, B, and C. So my A is negative 4, my B is negative 8, and my C value is 3. So my axis of symmetry is my x. So x is equal to the opposite of B, that's positive 8, over 2 times A, which is negative 4. That gives me 8 over negative 8, so x is equal to negative 1. Okay? So that's my axis of symmetry at x equals, drew it one too far over, x equals negative 1. That's my axis of symmetry. Now I need to find my y value, so that way I can make my vertex, because I know it's going to be negative 1 something. So I plug it into my equation. So I'm going to do my work down here. Negative 4 times negative 1 squared minus 8 times negative 1 plus 3. So negative 1 squared is 1 times 4 is negative 4. Negative 8 and negative 1 is positive 8, and then plus 3. So negative 4 plus 8 plus 3 gives me 7 for my y value. So that's going to be negative 1 and 7. So I'm going to go ahead and pull out that one. Okay. This one had a negative a value, so it's going to be opening down. So it's going to have a maximum. My y-intercept. So again, go back to our equation. If I put in 0 for x, that becomes 0. If I put in 0 for x, that becomes 0. And I'm just left with 3. So my y-intercept is 0, 3. So I know it's going to hit at that point. That's going to be one of my points here. Okay. My domain, x such that x is all real numbers. And my domain is going to be y such that y is less than or equal to, remember it's always that y value, 7. That's the peak in this case. So I go ahead and plug some numbers into my calculator and find my table of values. So I already knew 0 is going to be for 3, 1 is going to be negative 9, and 2 is going to be negative 29, which definitely is not going to fit on my graph. So I'm only going to be able to plot a couple of points. So I already have 0, 3, then I can do 1, negative 9, and then I can do their mirror images on the other side. And then I can draw my graph. Okay. So same steps. We got to use that x equals opposite of b over 2a to get myself started. That gives me my x value. I plug x back into the equation to find my y. That gives me my vertex. And then I go ahead and put it all in.